The late Jurassic was an empire built by giants, a world where the sheer scale of life almost defies modern comprehension. But in any empire, power is never absolute. It is contested, fought for, and seized by those built for the throne. For millions of years, that throne was occupied not by a single king, but by a dynasty, a family of killers whose very design defined the role of apex predator. Now, let's open the fossil record and resurrect the story of this Jurassic titan. The family is known to us as the Allosauridae, a lineage of large theropod dinosaurs that became the dominant terrestrial carnivores across North America, Europe, and potentially Africa. When we look at the fossil-rich layers of formations like the Morrison in the American West, we aren't just finding one or two skeletons. We are uncovering a dynasty's footprint. The blueprint for this success was a masterpiece of predatory evolution, a body plan refined for one purpose: the efficient subjugation of other colossal animals. Let's deconstruct this archetypal hunter. The skull of an Allosaurid is a paradox of lightweight construction and devastating power. It was large, but riddled with openings called fenestrae, which reduced weight without compromising structural integrity. This allowed for a highly mobile head capable of making rapid, precise strikes. The jaws themselves were not designed for a bone-crushing bite force like that of the later Tyrannosaurus rex. Instead, when we analyze the biomechanics, we see evidence for a slash and tear strategy. The teeth were serrated, laterally compressed blades, recurved to hook into flesh. The skull could withstand immense vertical force, allowing the animal to drive its upper jaw downward like a hatchet, inflicting massive, bleeding wounds that would weaken and fell even the largest prey. Moving down the body, the design for lethality continues. The forelimbs were surprisingly powerful and long for a theropod of its size, each armed with 3 formidable, sharply curved claws. These were not vestigial ornaments. They were grappling hooks, vital tools for seizing prey, preventing its escape, and potentially climbing onto the flanks of gigantic sauropods. This anatomical feature alone draws a sharp contrast with its evolutionary successors, highlighting a different, more hands-on approach to predation. The shaped neck provided the flexibility and shock absorption needed for violent struggles, while the torso housed a powerful musculature, anchored to a rigid spine. Powering this entire chassis were 2 robust hind legs, built not just for pursuit, but for endurance. And balancing the entire animal was the long, heavy, muscular tail, a critical counterbalance that provided the agility needed to outmaneuver prey, and just as importantly, to confront rivals of its own kind. This anatomical package was the gold standard for predation in the late Jurassic, a successful and repeatable formula for dominance. But this standardized design for lethality presents a fascinating ecological puzzle. The late Jurassic world, particularly the environment preserved in the Morrison Formation, was not home to a single, monolithic Allosaurid species. The fossil record reveals a more complex and dangerous reality. Several closely related, yet distinct, hunters shared this landscape. This wasn't one king ruling a kingdom. It was a dynasty of powerful, competing cousins, each armed with the same deadly toolkit. The central question then becomes, how could an ecosystem support multiple, massive apex predators, all seemingly built for the same job? The answer, we believe, lies in a delicate and violent ecological balancing act known as niche partitioning. When we analyze the fossil evidence, we can identify at least 2 major players within the immediate Allosaurid family coexisting in the same territory: the common and well-studied Allosaurus fragilis, and the rarer, more formidable giant, Saurophaganax maximus. Some paleontologists even classify Saurophaganax as a species of Allosaurus itself, making this a direct intra-family rivalry. And they were not alone. The powerful megalosaurid Torvosaurus tanneri also stalked these lands, adding another layer of competition. For these titans to coexist without driving each other to extinction, they had to carve out their own specific roles, or niches, within the broader ecosystem. The most straightforward partitioning mechanism is size. Allosaurus fragilis was a formidable animal, averaging around 8.5 meters, or 28 feet, in length. It was an agile and powerful hunter, perfectly capable of taking down large prey, but Saurophaganax was in a different league entirely. Estimates place it at 11 meters or more, making it one of the largest carnivores of the Jurassic, rivaling the later T-Rex in sheer scale. This size difference is not just a matter of record-keeping, it's a critical ecological clue. In modern ecosystems, larger predators typically hunt larger prey. It is therefore highly probable that Saurophaganax, with its more robust build and greater power, specialized in tackling the very largest animals in the environment, the colossal adult sauropods like Diplodocus and Brachiosaurus, whose sheer size would have deterred almost any other predator. This specialization would have left a different set of prey for its smaller cousin. Allosaurus fragilis, while still a giant, may have focused its efforts on more manageable, yet still dangerous, targets. We find compelling evidence for this in the fossil record. Puncture marks on the vertebrae of Stegosaurus match the teeth of Allosaurus perfectly, telling a story of ferocious confrontations. Bite marks on the bones of the ornithopod Camptosaurus suggest it was also on the menu. Furthermore, these more gracile allosaurids were likely the primary predators of juvenile and subadult sauropods, which would have been far more numerous and less defended than their titanic parents. They were the generalists, the adaptable opportunists of the family, thriving in the shadow of their colossal relatives by targeting a wider, more varied diet. This partitioning may have extended beyond just prey choice. It's possible these species favored slightly different habitats within the vast Jurassic floodplains. Perhaps the larger Saurophaganax kept to the more open areas where the largest sauropod herds congregated, while the more numerous Allosaurus fragilis found success hunting in the denser forests and along river corridors. But this delicate separation of roles was not a guarantee of peace. The territories of these apex predators would have inevitably overlapped, and flashpoints of conflict were unavoidable. A freshly killed sauropod, a contested water source during the dry season, or a simple territorial dispute would have brought these cousins into direct, violent confrontation. Here, size and power would have been the ultimate arbiters, with the larger animal almost certainly dominating the smaller. The hierarchy was real, and it was likely enforced with brutal efficiency, a constant, underlying tension in a world ruled by a family of killers. The theoretical lines we draw for niche partitioning separating these Jurassic titans by prey, choice, or habitat are often blurred and broken in the harsh reality of survival. For direct evidence of this violent, competitive world, we need only listen to the stories the fossils themselves tell. The bones of the Allosaurid dynasty are not pristine relics. They are scarred chronicles, pathological records of brutal lives lived on the edge. When we read these stone archives, the abstract concept of an apex hierarchy becomes terrifyingly concrete, written in fractures, punctures, and disease. Perhaps no single fossil tells this story better than the specimen known as Big Al, an exceptionally complete subadult Allosaurus. His skeleton is a roadmap of hardship. We have identified 19 distinct pathological injuries, ranging from healed rib fractures to damaged tail vertebrae. Most telling is a severe, chronic infection on the third toe of his right foot, a condition known as osteomyelitis. This would have been a crippling, painful injury, likely causing a persistent limp. How did he receive these wounds? The broken ribs could have come from a crushing blow delivered by the tail of a sauropod, a powerful kick from a Stegosaurus, or even a violent collision with a rival allosaur during a territorial dispute. The infected foot suggests a puncture that festered, impeding his ability to hunt, to run, to survive. Big Al's life, though relatively short, was one of constant struggle, a testament to the immense physical toll of being a Jurassic predator. This evidence of a difficult life is not an isolated case. The Cleveland Lloyd Dinosaur Quarry in Utah presents an even darker, more complex narrative. It is what paleontologists call a predator trap, a location with an overwhelming abundance of carnivore fossils, over 2/3 of which belong to Allosaurus. The leading theory suggests this was a muddy, treacherous waterhole during a prolonged dry season. Herbivores would become mired in the muck, their distress calls attracting predators from miles around. In their frenzy to scavenge the trapped prey, the Allosaurs would become stuck themselves, creating a vicious cycle of death and desperation. The sheer number of Allosaurus individuals, from juveniles to large adults, all trapped together, paints a grim picture of intense, intraspecific competition. In this desperate scenario, the normal rules of the hierarchy would have been enforced with lethal finality, with stronger Allosaurs likely preying on their weaker, trapped kin. The scars on the throne were often inflicted by those who shared the same bloodline. The brutal chronicle etched into these Allosaurid bones reveals a profound truth about their reign. Their violent lives were not an anomaly, but the very engine of the Jurassic ecosystem, a relentless pressure that shaped predator and prey alike. In their scars, we read the story not just of a dynasty's dominance, but of the intricate, high-stakes balance that governed this ancient, lost world.